Hello guys, welcome to 29.5 reversible reactions. In this lesson we are going to learn about what a reversible reaction is and what's this term called dynamic equilibrium. What does that actually mean in terms of the molecule? So let's have a look at this reaction here. You're going to get a chance to do this in class if you want to. Basically, you're going to put blue copper sulfate into a test tube and clamp it. You're going to need a Bunsen burner. As you heat that blue copper sulfate, it is going to drive off the water because the copper sulfate, when it's blue, is hydrated. In other words, it's got 5 water molecules. Now you'll notice a little dot down here. That little dot means that these water molecules are not actually chemically bonded to this copper sulfate. They are just there. If we heat, we drive off that water will come up this delivery tube and land in the test tube below, and the color change will happen. You will end up with just anhydrous copper sulfate, which is a kind of grey white color, and your 5 water molecules will be down here. For every 1 mole of copper sulfate you've got over there, you'll have 5 moles of water down here. Okay, so let's have a little look at that reaction in more detail. I would like you to consider 3 questions. How do you know the reaction is reversible? What would you expect to see if you added water to just the white anhydrous copper sulfate? And when we add water to the anhydrous copper sulfate, the reaction gets hot. What does this tell you about the backwards reaction going this way and the forwards reaction going this way? Okay, so let's see this in action. So you can see that this is the same setup that we had in the picture in the PowerPoint. You can see the blue hydrated copper sulfate there. So for every 1 mole of copper sulfate, there is 5 moles of water. And you can see already, just by giving it just a small amount of heat, you can see that the blue color is starting to leave the copper sulfate and it is starting to go white. If we have a look here in more detail, you can see that the color change is happening. Now we need to give it quite a bit of energy, which implies that this forward reaction is actually endothermic. We need to put energy in order to make it happen, which would imply that the reactants on the left-hand side of our equation, that they have more energy than the reactants on the right-hand side of the equation. As we drive off the water, you can see that there is some water vapor here, and that water vapor is going up the tube and it is coming down here and it is collecting in the delivery tube at the bottom. And that is why the color change is taking place. So you can see what we started with was copper sulfate with 5 water molecules, or hydrated copper sulfate. You can see what we ended up with over here was copper sulfate, and then all the water was driven off. This one's got no water, it's anhydrous. And those are the differences. Now, because of this little reversible reaction symbol here, if we add a little bit of water to the copper sulfate, it turns back blue again. So I asked you to consider some questions. How did you know the reaction was reversible? Because you had this symbol here. Whenever you see this symbol here, it means that the reaction can go in both the forward and the backward direction. What would you expect to see if you added water here? Well, it would turn blue again. And then if you heated it up, it would turn white again. And then if you added water again, it would turn blue again. So it's just forwards and backwards. And all it is the addition or the elimination of water. When we add water to the copper sulfate, the reaction gets hot. So we know that this way, the reaction is exothermic. Therefore, in the forward direction, the reaction must be endothermic. And there must be the same amount of energy changes that happen. I can show you for this reaction, blue to white, the reactant had less energy than the products. Because in the forward reaction, we get energy taken in from the surroundings. And that energy that we gave from the Bunsen burner has gone into the products. And then we end up with the white copper sulfate, the anhydrous version of it. But in the backwards reaction, when we started off with the white copper sulfate, we gave energy out to the surroundings. So the products, or the blue hydrated version, must have had less energy in it. And that's to do with the making and breaking of bonds. But you can see that our red arrows are exactly the same. All the energy that we put in, we get out again in the backwards direction.